Assalamu-Alaikum everyone. Welcome back to today's explainer. I am absolutely thrilled to have you here. Look, if you've ever felt a little intimidated by decimals, honestly, don't sweat it. Today we're going to dive into a fantastic lesson on mastering the multiplication of decimals. It's actually way easier than it looks, and by the time we wrap up, you'll literally be doing these calculations in your sleep.
So here's our game plan for today. We'll start with number 1, the golden shift rule. 2, scaling up with 100 and 1000. 3, decimal multiplication in action. 4, real-life word problems. And finally 5, test your skills.
Okay, let's dive right into Section 1, the golden shift rule. We are starting with the absolute most important foundational rule of the day. The rule of 10 states that when you multiply a decimal by 10, the decimal point shifts exactly one place to the right. I really want to emphasize this core mechanic for you. Because the number 10 has 1 0, that decimal takes exactly one jump to the right. It's just 1 0, one jump.
Want to see how this works in practice? Well, 0.87 times 10 transforms beautifully into 8.7 with just one simple shift of the decimal point. It basically just hops right over that 8. And it's the exact same for any number. If you've got 0.7, it takes one hop to become a whole 7. Or say you have 0.057, one jump right makes it 0.57. It really is as simple as that.
Let's move to Section 2 and see how this builds. Scaling up, 100 and 1000.
Now, what's really interesting about this is the undeniable, super simple pattern linking the number of zeros to the number of jumps. Check this out. 10 has 1 0, right? So we shift one place right. 100 has 2 zeros, so we shift 2 places right. And 1000 has 3 zeros, which means, yeah, you guessed it, 3 shifts to the right. The zeros literally tell you exactly how many steps your decimal needs to take.
Let's demonstrate this 100 rule in action. Because 100 has 2 zeros, the decimal in 0.19 jumps twice to the right. Hop, hop, and boom, it becomes the whole number 19. But wait, what if you run out of digits? Say you've got 0.03 times 100. The decimal jumps over the 0, then over the 3, and it becomes exactly 3. If you ever find yourself needing more space for your jumps, a 0 is automatically used as a placeholder.
And here is the 1000 rule. Say our starting decimal is 0.2. It's going to need to jump 3 times because, well, there are 3 zeros in 1000. We hop once over the 2 and, oops, we run out of digits. So we just pop in 2 extra zeros for those remaining 2 jumps, making our final answer 200. The exact same logic applies anywhere else. 0.12 becomes 120, and 0.214 becomes 214.
Let's transition right into Section 3, decimal multiplication in action.
Look at 3.6 times 100. We need to move the decimal 2 places here. We start at 3.6, jump once over the 6, and since we're out of numbers, we just add a 0 for that second jump. We land right at 360. This perfectly proves that the rule never, ever changes, no matter what decimal you start with.
Now let's look at 1.2 times 1000. Moving 3 places gives us 1200. We hop over the 2 and add 2 zeros for the remaining jumps. Just like 2.5 times 10 becomes 25 with a single jump, you can see that the decimal always moves to the right. It's incredibly consistent. And this brilliantly brings us to Section 4, real-life word problems.
Because math isn't just something on a chalkboard, right? It exists all around us. Here's our first practical challenge. Imagine a box contains 200 packets, and each packet has exactly 5.1 kilograms of flour. We need to find the total weight of the box. Now, I know seeing a decimal multiplied by a big number like 200 might look a little intimidating at first glance, right? But we can easily break this down into digestible steps. Scaling a decimal by a non-base 10 multiple, like 200, is honestly just a combination of simple multiplication and our familiar zero shift rules. Step 1. Just multiply the decimal 5.1 by the digit 2. That gives us 10.2. Step 2. Apply our shift. Since we're multiplying by 200, we have 2 zeros to deal with. That's exactly like multiplying by 100.
So we take that 10.2, shift the decimal 2 places to the right for those 2 zeros, and there it is, the incredibly satisfying final answer of 1,020 kilograms for the total weight of the flour. Easy, right?
Let's try our second word problem. Say a car travels exactly 1.25 kilometers every single minute. What's the total distance that car has traveled over a span of 20 minutes?
We are going to apply the exact same logic step by step. Step 1. Ignore the 0 for just a second and multiply 1.25 by 2. That gets us 2.5. Step 2. Now we bring back the 0 from the 20. That single 0 means we just shift our decimal one more time to the right.
And with that one final jump to the right, we arrive loudly and proudly at our answer, a total of 25 kilometers traveled by the car. See, when you really break it down, it's just basic multiplication combined with our golden shift rule.
All right, we've officially reached Section 5. Test your skills.
It's time to recap. So the absolute crucial points to remember today are: multiply by 10, it's 1 shift right. Multiply by 100, that's 2 shifts right. Multiply by 1,000, 3 shifts right. Always remember to add zeros if you run out of digits during your jumps. And lastly, never panic at word problems. Just break them down into those 2 easy steps. Now, I want to leave you with a final thought to test your actual mastery. I challenge you to pause this explainer right now and solve these 5 homework questions. Apply your shifts, use your placeholders, and see if you can break down that final word problem. Have you truly conquered the golden shift rule? Try it out for yourself. Thank you so much for learning with me today. Keep practicing, and all.
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.